Hello, in this video we are going to discuss how to bring your own payloads into Metasploit in an attempt to DAV evasion, but there's issues with that, why that doesn't necessarily work the best, which we'll cover later at the end of the video. But this is more focused on using the generic, custom, and other payload types to supply your own payloads instead of using Metasploit's default. For the first demonstration, we're going to be using Fodhelper, but instead of using the default payload, we're going to use a custom one. We already have a interpreter session, and then we've already set the payload. Instead of it being like the interpreter one, but set payload generic custom if you haven't already. And then for making it easier for people to recreate it as like a demonstration, we're going to create shell, reverse TCP, format raw, LHOST, E0 because it's just a local test box, LPORT, 1, 2, 3, 4, share, output, msfvenom, and it will create this. Now we need to set the full path, because if we set the payload file, there's no tab autocomplete. So we have to instead do full path, like so. And then because it's compiled as a 64-bit payload, we have to show targets, set our target to our correct architecture of our custom payload, and then on top of that we have to also set it in advanced. So set the architecture to x64 and set the platform to Windows, kind of like you would do in msfvenom if you were passing in a payload through standard in. Now let's listen. 1, 2, 3, 4. Let's make sure this is set correctly. Oh, we need to set the session. Perfect. Double check advanced. Looking good. Run this. And we get our show. When we check our permissions, we have the elevator permissions that the UAC bypass worked. Let's exit out of this and create our own payload. Actually, I'm just gonna do this one pane of this window. So we have our reverse shell in assembly format, and if we look at the file, our port is in hexadecimal format. Push our LHOST, our attacker IP address, and then push our port that we're using. But if you look at the hexadecimal values of our IP address, you can see that they're like backwards, and the reason for that is based on stack frames. So basically a very quick demonstration of that is basically when the bytes are going onto the stack. So because the IP addresses will be backwards, so first they'll be like 10, then 10. No, wait, it should be, it goes on backwards. So let's see. So let's say our IP address is 10, 10, 14, 4. It would go on backwards, so it'd go 4 first, and then 14, and then 10, 10, and then when it goes on off the stack, it will be in order. So it technically looks backwards, but it's not. to create that string, we can use this Python tool that has default, that I have like default. It's basically just some Python that basically formats the hex for us, which is nice. But that's already set where I like it on port 8443. Now to compile it. So we can compile it two different ways. We can compile it just to the raw shellcode, which is this raw builder script. We're using NASM to the assembly is 32-bit, so we have to specify NASM win32 for 32-bit. It will create it as an object, and then we will just copy the payload, the bytes, into just a raw bin file. So we can do raw and then our TCP. When you run file against raw.bin, it's just data, just like the msfvenom is just data. If we cat just raw, you can see it is just the shellcode. Now if we want an executable, we'll have to do one additional step, which is linking it basically with the LD command. So first, like before, we compile it to an object, and then we link it to an executable. So TCP, like so. Now we have our reverse shell. We could run like the reverse shell if we wanted to. Like for example, if we were listening on our port and we did wine z underline rev.exe, we would get a connection. But in this case, because we're wanting to run it through Fodhelper, we are going to supply the raw shellcode. So let's go back up to setting our payload file, and we're going to set it to just raw.bin, which was created when we compiled the assembly. Now when we run Fodhelper for the UAC bypass, we should get a shell down here. Oh, except because there's one issue that I didn't fix, I'll address that now. Because the shellcode is 32-bit, we'll have to rechange the target to 0 so that our target is 32-bit. And then our advanced settings are wrong now, so we'll have to set our architecture to x86. And then we'll have to set, the platform's still the same, Windows. But now our target is 32-bit for x86, and our architecture, double check advanced, is x86 for 32-bit. Now when we run, it should execute our payload, and we get a shell. Nice. Alright. Going back to the Windows machine, I have moved both of the files, just the assembly raw shellcode file and the compiled executable. If we want to run it through like threat check, no threat is found. If we want to run it through the other one, no threat is found. So you could try to use this in something custom, but the issues comes more for Defender flagging on components of the framework. Alright, next I will do a portion to PSExec. Why PSExec? Because we're going to cover the issue of why trying to use custom raw shellcode files might not always work. And the main reason is because of size. If we look at the module with the edit command, and we look at the, if we want to look at the module and work on it, we can see the payload space is only 3042 bits or bytes or whatever, and the total payload size is kind of small, which is a problem. No, stop. No, let's quit without saving. And then if we wanted to supply a payload that's too big, in the advanced options, which I've already ran, there is a set exe custom. However, it doesn't really work with PSExec, and I'll post the link to the blog post of why that's an issue. However, we can get around that by, instead of using the generic payload, which I'll run to show it working, I'm just using the blue machine on Hack the Box because it's very easy to get the credentials. So there's the generic normal payload you can use, but if we set the payload, what we're going to do is we're going to do Windows download exec. And you may have seen this on Sand's blog, which I'll post in the description below as well. But basically all we need to do is set our exe name, which can be whatever, and then the default is thread, and then the URL that we're hosting our payload from. To create the payload, I'm going to use my custom tool to create a basic reverse shell. So tool runner for LHOST tongue 0 for the VPN port, and then our output file. Going back here, we'll cancel the web server real quick. We'll run file on rev. We have our rev shell. Excellent. Now when we run this, it will call to the web server. Cha-ching. And we get a shell as system. Okay, perfect. To wrap things up at the end, I'm going to recover all the issues that I think are a problem with supplying your own payload with generic custom and or using other payload options like Windows download exec and or other. And I made this little diagram to help illustrate that a little bit more on draw.io. So you, the attacker, are running Metasploit framework with some module, and you sort of apply a custom payload, and the attempts to get over defender and get access to the machine of your victim. However, even if the payload gets over the defender, security solution might not mean that the logic or behavior of the Metasploit module is going to get over. So this might not get through, and then the security solution will flag a part of the exploit that needs to work for your payload to run, and the whole thing will fail. Which is probably the case of why people tend to use more malleable CT frameworks like Cobalt Strike and other variations of that, where when they have their whole attack chain, it's more modified. And that's about it. Oh wait, and let's say you create a custom payload that's too big for, like, let's say this is like way bigger for some reason. It's not going to fit in the module. It's not going to be compatible anymore, which can be an issue of consideration. Maybe the executable or however you've compiled it isn't compatible, like it's the right size, but it's not compatible with the module. No matter how much you try to run it, it's just not going to work, which is another issue, which really isn't on the defender side, but more on your client side of your machine not working properly. Some issue there. And that's about it. I hope you learned something, and I'll see you all in the uncertain future. If you have any comments, please let me know, and I'll keep you posted on the next one. Take care.